Assalamualaikum and very good morning. My name is Muhammad Arif Aiman bin Muhammad Husni and my matrix number is MA19254. So I will continue our presentation with objective. So the objective of the experiment 1 is for the free convection. Firstly, the objective is demonstration of free convection. Second, determination of free convection convective heat transfer to air from plate heater, and third, determination of free convective heat transfer to air from cylindrical plate heater, and number 4 is a determination of free convective heat transfer to air from finite heat plate, and the number 5 is a relationship between dissipated power with a surface temperature. Number 6 is comparison between the 3 different types of surface heater. And the last but not least, determination of Rayleigh number, Nusselt number, and heat loss of the surface heater. That's all from the objective experiment 1 free convection. So, for the experiment 2 objective, forced convection. The number 1 is the demonstration of forced convective convection. The number 2 is demonstration of forced convective heat transfer to air from vertical plate heater. Number 3, determination of forced convective heat transfer to air from cylindrical plate heater. Number 4, determination of forced convective heat transfer to air from finite heat plate. Number 5, the relationship between air velocity with surface temperature, and lastly is a comparison between the 4 different types of surface heater. So that's all objective. Next, basic equations. The rates of heat transfer from a surface to a fluid by convection given by Newton's law of cooling. Where A is the cross-section area, H is the heat transfer coefficient, Tm is the mean of the temperature. So next, for the procedure experiment that have 16 procedure. Number 1 is the place the free and forced convection apparatus on a level table and adjust the adjustable leveling hood is necessary. And second one is the plug the 3-pin plug to the 240 watt AC main power supply and turn on the power supply. Next, switch on the power supply unit in the front of the control panel. Next, select the desired test specimen. Record down the space of the selected test specimen. Please find appendix for the definition of the test specimen. Number 5 is to place the test specimen to the plate heater placement and lock it with the wings nut provided. Connect the test specimen heater cable to the heater socket which is located at the back of the control panel. Number 7 is the take the digital handled temperature probe and meter. Measure the initial temperature in the air duct by putting the temperature probe into temperature point E. Next, step number 8 is after read the temperature of the point E, place the temperature point to the point D and regulate the power supply to 50 watt by tuning the power regulator and keep an eye on the digital power meter. Next. The step number 4 is for every 5 minutes elapsed, measure the temperature at the point D and record it into a table. Next, continue the experiments until steady state achieved, where the temperature reading at point D become constant. Repeat the experiment with the power and repeat the experiment with different type of the specimen. Ensure the previous heat place is properly cooled before removing it. Next, from the temperature result obtained, calculate the film temperature. Then from the thermophysical properties of gases at atmospheric pressure table provided, extract all out the relevant information. Next, from the information obtained, so calculate the volumetric thermal expansion coefficient, Rayleigh's number, Nusselt's number using the correct equation. Last but not least, and finally, calculate the coefficient of convection heat transfer and hence the heat loss by convection using the correct equation.
Assalamualaikum and hi, my name is Nur Aina Safira binti Saladin and my ID is ME19318. So in this video, I'm going to present to you the data table and the calculations. So first of all, we have two tables. The first one is free convection calculated data and the second one will be the forced convection calculated data. So this is the table. So I will explain one by one. So first of all, we will start with converting the Celsius into Kelvin. So when we want to transfer the Celsius into Kelvin, we have to plus 273. And then next, to get the TF, we have to add TS and T infinity Kelvin and divide it into 2. Next, to get the beta, we have to 1 divided with TF. And then the G and also D have been provided in the lab sheet. And then for the rho, we have to find 87850. Next, CP, mu, V, K, alpha, PR, all of these we will get from the table 850. Next, for the RA, we will use this formula. For the NU, we will also use this formula. Next, for the H, we will use the formula NU multiply with K over T. And for the total T, we have to minus TS minus with the T infinity. And then for the Q, we have to multiply H, area of surface, and also total T. And next, for the NQ, we have to multiply Q with the 24. For the forced convection calculated data, so basically for the forced convection, we have to find the TS and TF. So we have to find two tables for these forced convections. The first one, we have to know the CP, rho, mu, V, K, and PRs for the S data, and the second one, we have to know all data for the TF data based on the TF data. So basically, TS, K, and the FK we will get from plus the TF Celsius with 273. And for the CP and the gangs, we will get it from the table 850. So next, for the Vmax, we will divide the V with the 3. For the C and M, we will get it from this table. For NU, we will get from this formula. And then for the H, Q, and NQ, we will use the same formula provided at the free convection calculated data. So I think that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Adam Mezakralwa, ME19150. So for this lab report, which is a heat convection, which heat transfer from one medium to another using a convection process by fluid or gas or plasma. So as for my part, which is the result for this lab, question 1 will be plot the graph temperature against time for free convection. For information, this lab we are using only cylindrical fins. So from the temperature versus time for free convection, it's shown that the higher the power, the more heat increases over time. For the second question, plot a graph against time for forced convection. In the free convection graph, the Q, which is the power, is different, which can say 25, 50, 25, and 100 watt. For the second question, we are using different velocity instead of power. So the velocity is 0.2 millisecond to 1.1. As you can see from the result, temperature against time for forced convection, as the longer velocity it takes is over time, the temperature will be reduced over time for higher velocity. So for question 3, mass flow rate, we don't calculate the heat transfer rate because I think Aina already covered part in the report. So mass flow rate, I took the data from Aina on the Excel. So using the formula, which is m dot, which is mass flow rate, equals to density and area times with velocity. So these are the results for the calculated when V equals to 0.2, 0.6 millisecond, 0.9, 1.1. That's it from me. The other, for question 4, we don't calculate it. So the next part will be continued to Lim. Alright, thank you so much.
I am joining with matrix number MA2006 and I'll present about the result. This graph shows the heat transfer coefficient versus the velocity for the forced convection. If you can see, the line is moved outwards. There are 4 graphs below, which is 0.2 millimeter per second, 0.6 meter per second, 0.9 meter per second, and 1.1 meter per second. And this graph shows the temperature versus the position 1, 2, and 3 for the forced convection during the experiment. And during the experiment process, we have found the T infinity is remain constant for the 4 velocity process, and the changes is Ts and also the Tf. This graph shows the 0.2 meter per second graph, this 0.6, 0.9, and also the 1.1.
Ready everyone, my name is Karim Kumar and my ID number is MA19020. So today I will be explaining the discussion part of the report. So let's have a look at the first discussion as well. As for the first discussion, discuss the variation of heat transfer in free convection mode for different powers. So basically, what are convection are? So convection is a process which is known as a process of heat through bulk movement of molecules within the medium, such as gases and liquids. And it only can be occurred through the gases and liquid particles. So there are reasons behind it, and we will discuss it in the later. To be more stated, there are 2 types of convection process to be happen, which is the natural convection and the forced convection, as you can see in the diagram below. So the natural convection occurs on its own, which the fluid is not generated by any external forces, and the forced motion is occurred by the external forces. So for the second question is to discuss the effect of air velocity to heat transfer characteristic for the forced convection mode. To be clear regarding the forced convection heat transfer, it is really will happen due to some influence of some external force, as we stated before, such as wind, pump, and agitation of fan. So the heat transfer process depends on the physical properties of the fluid, its temperature, flow velocity, the shape and the size of the passage in which the force flow is to be occurred. So the more the air velocity, the more the convection rate. As for the third question, indicate the difference between laminar and turbulent flow. Moreover, elaborate which of one of the has the highest heat transfer coefficient. As we can see, the laminar flow relativity occurs in the fluid flowing of a low velocity, and turbulent flow occurs when the fluid flow in the higher velocity. The heat transfer coefficient is higher in the turbulent flow, as under the turbulent flow coefficient, the increase in heat rate is more significant than in laminar flow. So that's the reason the turbulent flow is having the higher heat rate transfer rate compared with the laminar flow. This is due to the increase in Reynolds number in turbulent flow compared with the laminar flow. So for the next discussion, let's discuss the effect of convection mode on the several efficiencies. In mediums such as water, air, the coefficient is much more efficient because the intermolecular distance between each molecule in water and air more further compared with the solid particles. Thus, the further the particle freely can move and transfer. As we can see in the diagram below, the intermolecular state of the particle between the solid is very near apart, so it will be quite difficult for the heat to travel through the convection way. And as we can see, the intermolecular particle of the water and gas, it is further apart, so the convection heat can be offered very easily. So for the fifth, discuss the effect of the external surface of the heat convection. As we know, external surface is known as the free, as we can see in the picture below, are commonly employed to improve the rate of convection heat transfer between the solid and surrounding fluid due to some increased surface area of the cross section, where the convection process of the extended surface are employed to promote the heat transmission. So that's the reason of the extended surface, which is known as the free surface as well. So for the last discussion, we discussed the result obtained during the experiment. So the first experiment was the free convection. Determine the coefficient of the heat transfer, which is H, and the heat loss by the convection, which is Q in the experiment. In free convection, the heat loss is lesser because the air moves away from the heated body as the warm water rises and replaced by the air. For the second experiment, is the forcing convection. The heat loss is higher as the force will move across the body easily, and the efficient remove the heat from the body. So that's all from the discussion part. Thank you.
Assalamualaikum warahmatullahi taala wabarakatuh. My name is Puan Muhammad Izzat bin Tuan Muhammad Fauzi. My matric number MA19257. I'm from Group 6, Section 01. For my part, I will explain about the conclusion. For the first question of the conclusion, draw the conclusion based on the experimental data. To be concluded, we can know that the heat transfer rate and the heat loss by the convection do increase as the power supply increase. Other than that, we can know that the air velocity is directly proportional to the heat transfer rate and the heat loss rate. Next question, comment on the performance of free and forced heat convection. So as from the graph obtained after the results, we can conclude that the temperature at point D increase as the power supply increase is relative to the time. The graph of forced heat convection indicates that air velocity increase until it reaches 0.6 meter per second, then it moves a downward tendency after the 0.6 meter per second. For the last question, comment on the addition of extended surface for heat convection. So we can know that the length of fin is directly proportional towards the heat transfer rate. The temperature does reduce along the fin, following an exponential curve which explains why it took some time to reach the ambient temperature. Other than that, these extended surfaces are generally used to enhance the convective heat transfer rate between a solid and surrounding fluid. So this is the list of the references that we refer. So that's all from us, Group 6. Thank you.